10 Steps to Secure SQL Server. These 10 steps will guide you through some of the basic principles of database security and how to implement them. Isolate the database server. Production database servers should be isolated as much as possible from other applications and services. Dedicated DB servers have a smaller footprint and hence attack surface, and there's no need to worry about contending resources or conflicting traffic. Operating systems should be lean, with only the necessary services installed and running. Don't install other applications unless they are required by the database server. Depending on the size of your environment, you should consider putting your SQL server in a restricted network segment, VLAN, so that only authorized traffic can pass to it. Typically, only an application server or web server will be talking directly to the database. So fairly restrictive network policies can be enacted to prevent illicit connections. This should go without saying. But you should never open your database server up to the internet on ports 1433-1434, MS-SQL, and 3306-3307, MySQL. Tailor the DB installation. Both MS-SQL and MySQL offer tons of additional features, most of which you probably won't need for any particular instance. By removing the pieces you don't need, you reduce the possible inroads for exploitation. If you want to keep a feature around to play with that you aren't using yet, do it in a test or development environment. Best to keep production locked down as much as possible, especially before determining what effects a new module may have on your environment. Keep it updated. Both MS-SQL and MySQL are regularly patched, so be sure to keep your version up to date. Most vulnerabilities that get exploited have been known for over a year. So installing security patches in a timely manner can prevent the majority of attacks by simply sealing up these flaws. Having a regular patching schedule and protocol can help to implement updates in a test environment so any negative effects can be discovered without interrupting production. Many shops lack this luxury and fly by the seat of their pants, installing updates directly into production and hoping for the best, as well as exactly what the patch is changing. Restrict SQL traffic. As mentioned in Step 1, database servers typically only have another server, or several, connecting to it. If this is the case, access to the server on the database ports should be blocked everywhere else, by only allowing SQL traffic to and from designated IP addresses. You can be sure that a malicious actor or infected client inside the firewall doesn't hammer away at your server. In some instances, clients will need to connect directly to the database server itself, for example with a thick client front-end application. The same logic applies here, restricting those SQL connections to the specific IPs, or at least IP segment, that need it. Because these are endpoints, be sure to secure them properly, as malware can scan and attack SQL servers. You can handle this with IP tables on Linux, the Windows firewall, or preferably, a dedicated firewall device. Use least privilege when assigning permissions. Database users, like users on any system, should only have as much access as they need to perform their duties. also known as the principle of least privilege. Consider granting read access to views instead of directly to tables, to protect sensitive fields if necessary. Stored procedures. Maintenance plans and other automated tasks should be run as dedicated users with the appropriate permission set. This measure prevents any one piece of the database server, or any malicious or compromised user, from wrecking the whole system. Oftentimes application instructions will have you put their users in a full access admin role. This is against general best practice and typically represents either sloppy programming that requires more access than it should, or a desire to remove security from support considerations, neither of which has your data's best interest in mind. So always consider how implementing application accounts can affect your overall resiliency. Set a strong admin password. In MS SQL, the SA account is used whenever mixed-mode authentication is selected. Microsoft recommends using Windows Integrated Auth, but many applications require mixed mode to support their database users and connection strings. If you do have mixed mode auth enabled, be sure to secure the SA account with a complex password to prevent it being brute forced. Similarly, the root user for MySQL should have a complex password. If someone is scanning your database server, the first thing they are going to do is try to log in as the default admin account. So failure to lock it down can result in total system compromise. Audit DB logins. Part of your overall logging and monitoring should include login auditing for your SQL database. At the very least, these records will prove useful in forensic situations. But if regularly monitored or even integrated into an automated notification system, repeated failed logins can alert of attacks and other issues before they become critical. Allowing you to disable compromised users or change their passwords, while logging successful logins keeps a record of which admins, users and applications have connected, helping troubleshooting and change management. Secure your backups. Guess what? Your backups have the same data as your production databases and need to be secured with as much care as the server itself. This can mean locking down backup directories, restricting access to the server or storage hosting the data, physical security of removable media, network access to backups and reviewing who has access to perform and access backups. Protect against SQL injection. When a web application accepts user input and sends it to the database, unsanitized data can inject malicious code into the server and perform unauthorized tasks, including getting full shell access, depending on the server's configuration. Called an SQL injection, there are several ways to mitigate these attacks, including step 6 above. Restricting the ability users to perform unauthorized tasks, but there's really only one way to prevent them. And that's to utilize stored procedures instead of direct SQL queries for web app interaction. Stored procedures only accept pre-established parameters and can only perform very specific functions, so they prevent the injection of data into a raw SQL query. Thank you for watching. Please subscribe to this channel for more informative videos.